Bro, it's so hot today, bro.
We really need to find some shade.
Bro, it's so hot today, bro.
We really need to find some shade.
Yo, check it out, dude. It's some shade.
Oh, some shade.
Oh, finally, bro.
Oh,
Wow, that's a lot of shade. I wonder where it's coming from.
it's from the tree, dummy.
Wow, that's the biggest tree I've ever seen.
It's a redwood, tallest type of tree in the world.
Yo, wow, that's so cool, bro. I wonder how tall it is.
No way to find out. Way too tall to measure.
Guess we'll never know how tall the tree is.
Wait, I think I know how to find the height of the tree.
Wait, really? How are you supposed to do it? It's literally impossible to measure it.
Use proportionality to find out how tall the tree is.
Bro, what is proportion what, bro?
In this video, we'll show how math helps solve a real-life problem, finding the height of a tree using shadows. We'll also connect this to the major theorems from our unit on similarity.
The tree itself is not a triangle, but the tree, ground, and the sunlight form a triangle. The height of the tree is one side, the shadow on the ground is the other side, and the sunlight from the top of the tree to the end of the shadow makes the slanted side.
So both the person and the tree create triangles?
That's exactly how it works.
So if the sides are similar, then they match in proportion?
Exactly. Both the person and the tree triangle have a right angle because the height is vertical and the ground is horizontal. They also share the same angle of sunlight. Since two angles match, the triangles are similar by the AA similarity theorem. AA similarity theorem stands for the angle-angle similarity theorem.
You're saying that we can find the height of a tree by finding the height of the tree shadow and our shadow?
Wow, that's insane. Let's get started.
The first step is to measure Aiden. Aiden is approximately 5 foot and 7 inches.
Now we're supposed to measure my shadow, right?
Yes. Aiden's shadow is approximately 4 foot 5 inches.
Now we have to measure the tree shadow.
The height of the shadow is approximately 75 feet and 5 inches. Because triangles are similar, corresponding sides are proportional. We calculate the person's height over the person's shadow being equal to the tree's height over tree's shadow. So 67 over 53 is equal to 905 over our answer. After cross multiplying, our answer is around 716 inches, which is 59 feet and 8 inches.
Whoa, that was actually so cool, man.
Man, we just use math and shadows to find out the height of a huge tree that can't normally be measured.
The tree example mainly uses AA similarity and proportionality, but our unit included other theorems as well.
The SSS similarity theorem says that if all three pairs of corresponding sides of two triangles are proportional, then the triangles are similar.
So with SSS, you don't need any angles, you only need side ratios.
Yeah, you're right. The SAS similarity theorem says if two pairs of corresponding sides are similar and the included angle is congruent, then the triangles are similar.
SS uses the 3 side angles, AA needs no sides, and SAS uses 2 side angles and the angle included between them.
Exactly, you're getting it. Perimeters of similar polygon theorem says that if two polygons are similar, then the ratio of their perimeters equal the ratio of corresponding side lengths.
Wait, so if the shape is scaled up 3/2, then its perimeter is also scaled up the same way?
Yes, you guys are doing so well. The area of similar polygon theorem says that the ratio of areas is the square of the scale factor.
So the area grows faster than the side length?
That's correct, because the area is two-dimensional. Another theorem is the triangle proportionality theorem. This means if you draw a line parallel to one side of a triangle, it creates matching ratios on the other two sides.
Basically, parallel lines that make ratios consistent.
So splitting an angle makes a proportion on the other side.
The converse says if a line divides two sides proportionally, then that line must be parallel to the third side.
So that's just the reverse data.
Perfect. Three parallel lines theorem says that if three parallel lines intersect two transversals, they divide those transversals proportionally. The angle bisector theorem says that if a ray bisects an angle at a triangle, It divides the opposite sides into segments proportional to the other two sides.
Hey, I'm starting to understand this really well now.
These theorems are useful in life.
AA similarity can be used to estimate the lengths and heights of certain objects such as the trees, flagpoles, and others.
SSS and SAS are especially useful in construction and engineering to help with shapes and drawings.
Triangle proportionality and angle bisectors are used in geometry, structural design, surveying, and so much more.
Today we use shadows to find the height of the tree.
See, that worked because the person triangle and the tree triangle were similar by the AA singularity theorem, with the angle from the sunlight and the right angle at the ground being the same.
Then we use proportionality to solve for the missing height.
Math helps us understand the real world. Thank you so much for watching.